Welcome to this notebook about AI in business. In Chapter 1, we explore what AI can and cannot do. Core categories like automation, insights, personalization, and forecasting, and real-world case studies. Chapter 2 covers the AI project lifecycle, including identifying problems, checking data readiness, and deciding between building or buying solutions. Chapter 3 introduces essential tools and platforms, from no-code tools like Power BI and Data Robot, to code-based tools like Python, Jupyter, Pandas, and Scikit-learn, and cloud AI services such as Azure ML, AWS SageMaker, and Google Vertex AI. Chapter 4 focuses on data handling, including collection, cleaning, formatting, and working with structured and unstructured data. Chapter 5 teaches building AI models with classification, regression, clustering, and using Scikit-learn on real datasets. Introduction to AI in business. What AI can and can't do in business. In this page, we will understand what artificial intelligence can and cannot do in a business setting. Let's start with what AI can do. AI can automate repetitive tasks like data entry, report generation, and email responses. It can analyze large volumes of data faster than humans. AI is good at detecting patterns and trends that are hard to see manually. It also helps in improving decision-making by providing data-driven insights. And finally, AI can personalize customer experiences by tailoring recommendations, messages, or services. Now, let's look at what AI cannot do. AI still struggles to understand human context or emotions the way a person does. It cannot make judgment-based decisions that rely on values, ethics, or intuition. AI is also useless without quality data. Messy or biased data leads to poor outcomes. And very importantly, AI does not replace all human jobs. It usually augments human work, not eliminates it. Core AI categories in business. This slide presents the main categories of AI used in business today. We begin with automation. AI reduces repetitive tasks, such as sorting documents or answering common questions using chatbots. Next is insights. AI detects patterns in complex data. This helps in discovering trends, making predictions, or identifying unusual behavior. Then we have personalization. AI tailors experiences for each user, like recommending products or customizing web content. The fourth category is forecasting. By analyzing historical data, AI can predict future trends, such as sales, demand, or customer churn. Now let's add two important modern categories. The fifth is language understanding, powered by large language models. These are used for chatbots, email summarization, auto-generated reports, and even customer support automation. They understand and generate human-like text. The sixth is computer vision. This includes image recognition, face detection, scanning documents, and video analytics, all powered by AI. It's used in sectors like retail for shelf tracking or manufacturing for quality checks. Together, these 6 categories cover how AI supports business workflows. Case studies: retail, finance, marketing, HR. In this slide, we explore how AI is applied across a wide range of industries, beyond just retail and finance. Retail uses AI for product recommendations, managing inventory with computer vision, and letting customers search products using images. Finance applies AI in fraud detection, risk scoring for loans, and extracting data from scanned documents like bank statements. Marketing teams use AI to segment customers, test and adjust advertising campaigns, and generate content like ad copy or emails with large language models. In human resources, AI helps screen resumes, predict employee attrition, and power chatbots that assist candidates during hiring. Healthcare is a major area for AI. AI analyzes medical images to detect diseases, predicts patient outcomes, and assists doctors in making faster, data-backed diagnoses. In manufacturing, computer vision is used for quality control, detecting defects in real time. AI also powers predictive maintenance, alerting teams before machines fail, and improves production efficiency. In education, AI enables personalized learning paths, automatically grades assignments, and supports tutoring using conversational agents or chatbots. These real-world examples show that AI isn't limited to one or two industries. It's reshaping how many different sectors operate, solve problems, and serve people. AI project lifecycle in business. Identifying business problems solvable by AI. In this slide, we'll learn how to identify business problems that are a good fit for AI. Not every task should or can be solved with artificial intelligence. So how do we know when AI is the right tool? First, the problem must involve data, and lots of it. AI works best when it has access to large, historical datasets, either structured, like tables, or unstructured, like text or images. A problem must benefit from pattern recognition or prediction. If the goal is to detect fraud, forecast sales, classify customers, or recommend actions, AI is a great match. Third, AI is ideal when you need to automate repetitive and rule-based tasks, like sorting emails, tagging images, or scanning documents. Fourth, the problem must have a clear business goal or a measurable outcome. This might be reducing customer churn, increasing click-through rates, or saving time on manual labor. Finally, AI works with probabilistic answers, not exact ones. If you're okay with AI saying there's a 90% chance a customer will churn, instead of giving a definite yes or no, then the problem is likely solvable with AI. So in summary, good AI problems are data-rich, pattern-based, automatable, goal-driven, and tolerant of uncertainty. Data readiness checklist. Before building any AI solution, you need to make sure your data is ready. This slide gives you a practical checklist to assess data readiness before starting any AI development. First, check that the data exists and is easily accessible. If your data is locked in PDFs, emails, or outdated systems, it may take more effort just to extract it than to train your model. Second, your data should be clean and well labeled. Missing values, duplicate records, or inconsistent formats can confuse the AI model. For supervised learning, you also need correct labels, like spam or not spam, to guide training. Third, you must have enough examples to train the model. Small datasets lead to poor performance. As a rule of thumb, hundreds or thousands of samples per class is a good starting point. Fourth, make sure the data matches the business goal. If you're trying to predict customer churn, you'll need customer histories, not just demographics. Fifth, always verify privacy and compliance. Check if the data includes personal or sensitive information. Ensure your use of data follows legal and ethical guidelines like GDPR or HIPAA. And finally, be aware of biases and gaps in the data. If the data only covers certain customers or time periods, the model might be unfair or inaccurate in production. Build versus buy. When to use off-the-shelf solutions. One of the most important early decisions in an AI project is choosing whether to build your own model or buy an existing solution. Let's first look at when it makes sense to build your own AI. Choose this path if your problem is unique and cannot be solved by generic tools. You might also want to build when the AI model itself is your competitive advantage, something your competitors do not have. If you have proprietary data that no one else can access, building your own model allows you to fully leverage that data. And of course, You should only build if you have a team with the in-house AI expertise to design, train, and maintain the solution. Now, when should you buy an off-the-shelf solution? This makes sense if the problem is common, like OCR for scanning documents, chatbots, or speech-to-text transcription. If you need fast deployment without months of development, pre-built solutions are ideal. They are also a good choice if your team has limited AI expertise. And for smaller budgets, buying can be more cost-effective because you skip the expensive training phase. In short, build for unique, high-value problems where you have the skills and data. Buy for common, well-understood problems where speed and cost are priorities. Essential tools and platforms. No-code, low-code tools. In this slide, we'll explore no-code and low-code AI tools. These are platforms that allow you to create AI-powered solutions without writing complex code. These tools use drag-and-drop interfaces, templates, and built-in AI models to make development much faster. They are ideal for business teams, analysts, and non-technical users who still need AI capabilities. Let's look at 3 popular examples. First, Power BI. This is a Microsoft tool mainly used for data visualization, but it also includes AI features like sentiment analysis, key driver detection, and forecasting, all without code. Second, Data Robot. This is an automated machine learning platform. It handles data pre-processing, model selection, and performance tuning for you. You simply upload your dataset, choose your target variable, and Data Robot trains and evaluates multiple models automatically. Third, Scikit-learn. This platform specializes in text analysis. It can classify customer support tickets, extract keywords, or run sentiment analysis, all through a simple web interface. The main advantages of no-code and low-code AI tools are speed, ease of use, and lower cost of development. However, they can be less flexible for highly customized AI tasks, and that's where code-based tools come in, which we'll cover next. Code-based tools. In this slide, we will focus on code-based AI tools. These are the tools used by data scientists and AI engineers to build fully customized solutions. Python is the most popular programming language for AI development. It has a massive ecosystem of AI and data science libraries, making it ideal for both beginners and experts. Jupyter Notebook is an interactive coding environment. It lets you write Python code, see results instantly, and mix code with text explanations and visualizations, which is great for experimentation and tutorials. Pandas is a Python library for working with structured data. It allows you to clean data, handle missing values, and perform quick analysis on datasets stored in tables. Scikit-learn is a machine learning library in Python. It includes ready-to-use algorithms for classification, regression, clustering, and more, all with consistent and easy-to-use syntax. The main benefit of code-based tools is flexibility. You can design models exactly the way you need, handle large or complex datasets, and integrate the results into any application or system. However, they require coding skills and take more time to set up than no-code or low-code platforms. Cloud AI services. In this slide, we'll explore cloud AI services, platforms that let you build, train, and deploy AI models without managing your own servers. The first advantage of cloud AI is scalable computing power. You can train large models on powerful machines without buying expensive hardware. You simply pay for the resources you use. Second, these platforms provide pre-built AI APIs for common tasks like speech recognition, translation, image analysis, and sentiment detection. Third, they make it easy to deploy and monitor AI models. You can push a model to production, track its performance, and update it, all from one platform. Let's look at 3 leading examples. Azure Machine Learning is Microsoft's cloud AI platform. It supports custom model training, automated machine learning, and full MLOps pipelines for managing models in production. AWS SageMaker from Amazon is an end-to-end machine learning service. It handles data preparation, model training, tuning, deployment, and monitoring, all in a single environment. Google Vertex AI is Google's unified AI platform. It combines AutoML, custom model training, and AI APIs under one roof, making it easy to go from data to deployed solution. Cloud AI services are especially useful for projects that require speed, scalability, and easy integration with existing business systems. Data handling for business AI. Practical data collection and cleaning. Before building any AI model, we need to collect and clean our data. This step is often the most time-consuming, but it is also the most important for good AI results. Let's start with data collection. The easiest source is your existing business systems, such as CRM platforms, transaction logs, or support ticket databases. You can also use public datasets and APIs. Many organizations publish open data that can be directly used for AI training. For physical operations, sensors and Internet of Things devices may generate real-time data, such as temperature readings, machine performance, or product counts. Another option is web scraping, where tools automatically extract information from websites, but you must respect legal and ethical guidelines when doing this. Next is data cleaning. AI models are very sensitive to messy data, so cleaning is essential. We remove duplicates to avoid biasing results. We handle missing values, either by filling them in or removing the affected records. We standardize formats so that dates, currencies, and units are consistent. And finally, we correct obvious errors, such as invalid product IDs or negative sales numbers. A clean dataset is the foundation for any reliable AI system. If you skip or rush this step, even the best AI algorithms will perform poorly. Data formatting for models. Once data is collected and cleaned, the next step is data formatting. AI models expect inputs in a specific structure, and if the format is wrong, performance will drop sharply. First, we often need to convert features to numerical values. Most AI models work only with numbers, so text, dates, or categories must be converted to numerical form. For categorical data, like small, medium, or large, we use encoding techniques. The two most common are one-hot encoding, which creates separate columns for each category, and label encoding, which assigns a number to each category. Next, we normalize or scale values so that different features are in the same range. For example, product prices and customer ages are on completely different scales, and scaling helps the model treat them fairly. Finally, we split the dataset into three parts: training data, which the model learns from, validation data, used to tune parameters during development, and test data, used to measure final performance on unseen examples. Good data formatting ensures the model can understand and learn from your data effectively. Working with structured and unstructured data. In AI projects, data usually falls into two broad categories: structured and unstructured, and each requires a different approach. Structured data is highly organized, stored in rows and columns, and fits neatly into tables. Examples include sales records, customer details, and product inventories. Common formats are CSV files, Excel spreadsheets, and SQL databases. This type of data is easy to query, filter, and feed into AI models after basic preprocessing. Unstructured data does not follow a fixed format. This includes text like customer emails, chat logs, and documents. It also includes images and videos, such as product photos or security camera footage, and audio recordings like call center conversations. Because it's less organized, unstructured data requires special preprocessing. For example, text data might need tokenization or sentiment analysis. Images need resizing and normalization, and audio might need to be converted into spectrograms before model training. Most real-world AI solutions combine both types. For instance, a customer feedback analysis tool might use structured data like ratings alongside unstructured text from reviews. Understanding the differences and preparing each type correctly is key to building accurate, reliable AI models. Classification. In this slide, we will learn about classification models, one of the most common AI approaches used in business. Classification is used when the output is a category instead of a number. The goal is to assign each input to a class or label. For example, yes or no, fraud or not fraud, or high risk versus low risk. Let's look at two important business applications. The first is customer churn prediction. Here, the model predicts whether a customer is likely to stop doing business with you. It uses data such as past purchases, service usage, and support interactions to classify customers as likely to churn or likely to stay. The second is fraud detection. In this case, the model analyzes transaction data and flags suspicious patterns that may indicate fraud. For example, multiple purchases in different countries within minutes could trigger a fraud alert. Some popular algorithms for classification include logistic regression, decision trees, random forest, and support vector machines. Each has strengths and trade-offs in terms of accuracy, speed, and interpretability. The key takeaway is, use classification when your problem is about categorizing something rather than predicting a continuous number. Regression. In this slide, we will explore regression models, another key AI technique used in business. Regression is used when the output is a continuous number, not a category. Instead of asking yes or no, regression answers how much or how many. Let's look at two common business applications. The first is sales forecasting. Here, the model predicts future sales based on past sales data, seasonal trends, marketing spend, and other influencing factors. This helps businesses plan inventory, staffing, and budgets. The second example is price prediction. In real estate, for example, regression models can estimate the value of a property based on location, size, and features. In retail, it might predict the best-selling price for a product. Popular algorithms for regression include linear regression, decision tree regression, random forest regression, and gradient boosting methods. These models differ in complexity and accuracy, and the right choice depends on the size of the dataset and the patterns in the data. The main point is, use regression when your business problem requires predicting a number, such as revenue, demand, or cost. Clustering. Now let's talk about clustering models, a powerful tool for discovering hidden patterns in business data. Clustering is an unsupervised learning technique. This means the model is not given predefined labels. Instead, it automatically groups similar items based on their features. One important application is customer segmentation. By analyzing customer purchase history, website activity, and demographics, a clustering model can group customers into segments such as bargain hunters, loyal premium buyers, or occasional shoppers. These segments help businesses create targeted marketing campaigns and personalized offers. Another example is market grouping. Clustering can identify regions or products with similar sales patterns, helping companies plan distribution strategies or decide which products to launch in specific areas. Popular clustering algorithms include k-means, which is fast and widely used, hierarchical clustering, which creates tree-like groupings, and db-scan, which can handle clusters of different shapes and sizes. The main idea is, use clustering when you need to discover natural groupings in your data without predefined categories. Using Scikit-learn with real datasets. Now that we know the three main types of AI models for business, classification, regression, and clustering. Let's see how to actually use them with Scikit-learn. Scikit-learn is a popular Python library for machine learning. It is designed to be beginner-friendly, while still powerful enough for real business projects. A typical Scikit-learn workflow has 4 main steps. First, load your dataset. This could be from a CSV file, an SQL database, or even a built-in dataset like Iris for classification or Boston Housing for regression. Second, pre-process your data. This might include handling missing values, scaling numeric features, or splitting the data into training and test sets. Third, train your model. Depending on the problem, you might choose a classification model like logistic regression, a regression model like random forest regression, or a clustering algorithm like k-means. Finally, evaluate the model's performance. For classification, you might use accuracy or F1 score. For regression, metrics like R-squared or mean-squared error. For clustering, measures like silhouette score. By following this workflow, you can quickly move from raw business data to actionable AI insights. Deep learning and custom models. So far, we've looked at Scikit-learn models, which work well for many business problems. But some use cases require deep learning or fully custom models. Deep learning uses neural networks with many layers, allowing the model to automatically learn complex patterns in data. It is especially powerful for tasks like computer vision, where the model interprets images, and natural language processing, where it understands and generates human language. It's also useful for complex forecasting, when relationships in the data are highly nonlinear. When you need more control or specialized features, you can create custom models. For example, a retailer might design the neural network that predicts demand based on product images, descriptions, and seasonal trends all at once. A bank might build a model that combines transaction history and text from customer support tickets to detect fraud. Popular frameworks for building these models include TensorFlow and PyTorch. These allow you to design, train, and fine-tune models for your exact business needs. The main takeaway is, use deep learning and custom models when your business problem involves complex data types or requires highly specialized solutions that standard algorithms cannot handle.
Thanks for watching.